Question number 4. Find the area of the largest rectangle that can be inscribed in a semicircle. It means what, everyone? Semicircle means, in this case, upper half circle of radius r. So take a look at the left-hand side screen. Suppose, everyone, we have a semicircle with radius r. Our goal is to place a rectangle, largest rectangle possible, inside this semicircle and find the area of that rectangle. That's our goal. So step 1 is finished. Step 2, sketch a diagram which is similar to what they have. Suppose, everyone, we sketch a rectangle with a radius r, something like this. We have upper half circle, and our goal is to put the largest rectangle possible. So just randomly draw a rectangle inside this upper half circle. Okay, everyone? Then surely we don't know how much x is. That means x is unknown. The height of the rectangle is also unknown. Let's call it y. Everyone, what is the length of this rectangle? The length of this rectangle is x plus x, which is 2x. What is the width of the rectangle or height of the rectangle here? It is y. Everyone, the area of this rectangle is length times by height, or some people call it length times by the width. So 2xy is our area. But before I move on to step 3, let me tell you one more thing, which is something to do with the radius r and then the upper half circle. Do you believe that this upper half circle has equation like this? X squared plus y squared equal to r squared. And if you solve for the y, do you believe that y squared is equal to r squared? Take away x squared. And then, because I'm solving for the y, square root both sides, our y is equal to plus and minus square root of r squared minus x squared. Tell me, everyone, if I have to reject one of them, either positive sign or negative sign, which one should I reject? If you said negative sign, you have to reject, then you're correct. Do you think we have the lower half circle as well, or only upper half circle? If you said only upper half circle, then you have to reject the negative sign. Do you know what this means? It means we only consider the plus sign. So our y is basically positive square root of r squared minus x squared. That's what I'm trying to tell you about. Let me put a big box, 2 boxes that are important for step number 3, when we are trying to find out the function that we're going to maximize or minimize. But this time we're going to maximize. The function that we need to maximize is the area 2xy. However, do you guys like 2 unknown variables in one equation? I guess no, unless you're in MATH100 for multivariable calculus. We don't like to have two different unknown values. So why don't we just substitute root r squared minus x squared into the y? Then that's going to be the function that we're going to maximize, which is the area function. The area function is equal to 2 times by x times by this. Are you guys okay if I write, instead of square root blah blah blah, I write r squared minus x squared to the power of 1/2? Hopefully you guys know that they're same. The reason why I write this way, it's because it's so easy to apply the product rule at the end. For now, let's find out step 4, which is the domain of this function. Technically, x is going from 0 to the radius r. Like I mentioned before, everyone, x is actually going from, look, it's going from 0 and the maximum x value of r. That's why the domain of this function is going from 0 to r. Next, we're going to find the derivative of this guy using the product rule. The derivative of a is the derivative of the first guy times by the original second. I'm just gonna write down the radical now. Plus the original first guy times by the derivative of the second. But please do not forget about the derivative of the inside. The derivative of the inside is negative 2x. So did you guys notice that 2 and 2 cancel? X and x multiply together. So everyone, if you simplify this whole thing, then you end up having 2x squared divided by square root of r squared minus x squared. Now, we need to simplify this a little bit by making the common denominator. Right now, there's a hidden 1 as a denominator, right everyone? So why don't you multiply top and bottom by this denominator, square root of r squared minus x squared, like this. Like this, everyone. And then, now we have same denominator, right? Left-hand side, right-hand side, same denominator. We can combine them together to make a single fraction. This is the single fraction that we have for the a prime of x. So combine the like terms, and we get, in order to find out the critical numbers, you guys know that we have to solve this derivative equal to 0. And there are two types of critical numbers. Number 1, it's coming from the numerator. Number 2, it's coming from the denominator. For type 2, it's easy, so let's do it quickly. Think about which x makes the denominator 0. In this case, when x is equal to r, then r squared minus r squared makes it 0. So type 2 critical number is x equal to r. But I'm more interested in finding the type 1. We just have to solve for the numerator equal to 0, like this. Do you understand, everyone, so far? X squared equal to 1/2 r squared, and then you square root both sides. I'm only going to consider the positive case of the x value because if you remember from our sketch, we're considering the positive x value right now. So that's why I'm going to consider x equal to r over square root of 2 as our type 1 critical number. Now, you have choices. You can use the number line to find out it's a local max, or you're welcome to jump right to the table of values. Our domain is going from 0 to r. And then the critical number is r over square root of 2. Our goal is to find out the area when x is 0, area when x is r, the area when x is this. If I go back to our area function, when x is 0, 0 times anything is 0. When x is r, r squared minus r squared is 0. Now, we just have to plug this number into our area function. So let's do it. Area of r over root 2 is equal to 2 times r over root 2 times by r squared minus 2 over r root 2 square root. Everyone, first I'm going to get rid of the bracket and try to simplify the inside the radical here. We have r squared minus r squared over 2, so it becomes, we have root 2r squared minus r squared over 2. 2r squared minus r squared becomes just r squared. Then we have root r squared over 2 becomes r over square root of 2. The good news we have is we can now combine this and this together to make it 2r squared times by 2. And finally, our area with the critical number is actually a very simple number, r squared. So this means our table here looks like r squared. Do you agree that this r squared, the radius, is more higher than 0 and 0? So this is our absolute maximum area for the function. Thank you, everyone. This is the end of question number 4. Have a great day.